Welcome to this lecture. Today we are going to deal with these topics little quickly but in detailed approach. My name is Gunjan Subedi and as always I'll be guiding you in this topic with practical explanation and examples when necessary. Before starting, let me kindly remind you to subscribe to my Lean University, which is my initiative to deliver free and quality professional education to your screen. With this example here, we are going to learn about the Kruskal-Wallis or one-way non-parametric ANOVA. So Kruskal-Wallis is also called the one-way non-parametric ANOVA. Here in this example, we are studying about the defects produced by 4 different machines: Machine A, Machine B, Machine C and Machine D. And we are counting the defects per 100,000 parts produced. So Machine A produces 150 number of defects per 100,000 parts produced on Sunday. Similarly, it produces 100 defects per 100,000 items produced on Sunday, and so on. So in this example, what we are interested is finding out whether there is a significant statistical difference between the defects produced per 100,000 items by Machine A, Machine B, Machine C or Machine D on different 8 days. Before running the test in Minitab, we convert it in a different kinds of worksheet. We write all the defects in one column with the corresponding machine. For example, first of all, we write the defects produced by Machine A, then Machine B, Machine C, and Machine D. After that, we go to the stat and we go to the non-parametrics. As you can see here, there are different tests for the non-parametrics. We are interested in the Kruskal-Wallis, so we click on the Kruskal-Wallis. Here in the response tab, we select the defects. We can double click the defects or highlight the defect and then click on the select. On the factor, we select the machine and at last we click the OK. We see here that the Kruskal-Wallis test for defects versus the machine is produced. We have 4 machines with their corresponding Z value and the P value. Here, the null hypothesis says all medians are equal. Since we are performing our non-parametric test, we are looking the medians over here. There is no difference between the defects produced by Machine A, Machine B, Machine C and Machine D. And the alternative hypothesis says at least one median is different. That means there is a statistical difference in the defects produced by at least one of the machine. So we are interested in the P value here. P value is 0.002, which is lesser than alpha value of 0.05. What does it mean? It means that we reject the null hypothesis since P value is far lesser than alpha. What does the alternative hypothesis suggest? There is at least one median which is different, or there is at least one machine which is producing statistically different number of defects compared to other machines. Before ending this lecture, let me remind you to join my Lean University's premium membership and enjoy a total free access for limited time inside my Lean University's online library and get tons of free courses, free books and lecture topics on project management, Lean and Six Sigma, operations and supply chain, productive and preventive maintenance, quality maintenance, data science, industry and sales management, agile and scrum, Kaizen or continuous improvement and much more totally free. No strings attached. As we have limited seats, only the early subscribers will be given open access inside the premium membership, and remember, it's totally free. Please subscribe and share the video if you share the common belief that professional education should be accessible to all.